Right now, fragments of an interstellar visitor, traveling over 97,000 kilometers per hour, are slicing through the void between worlds. Once a single icy wanderer known as 3I Atlas, it has fractured into a cascade of cosmic shrapnel, spreading like glass across the black. Each shard carries a signature, unlike any comet born of our sun. Because this one comes from another star, and the question now haunting scientists is simple. What happens if one of those fragments finds Earth's path at the edge of the solar system? Nearly 5 billion kilometers from the sun, a faint glimmer crosses the field of a telescope atop Mauna Loa. Its trajectory is wrong, its motion too straight, too swift, too free. The object cuts through the darkness at nearly 97,000 kilometers per hour, unbound by the gravitational leash that governs every planet, moon, and comet of our star. Its name will be 3I Atlas, and it will become only the third confirmed interstellar object humanity has ever witnessed. But even in its first moments of discovery, something about 3I Atlas resists classification. Its light curve wavers unpredictably, pulsing in erratic intervals, as if the object itself were trembling. Every rotation brings new brightness, new dimness, new inconsistencies no solar-born comet should display. This is no ordinary traveler. Its greenish hue hints at carbon chains and diatomic radicals, molecules born in colder, darker nurseries than our own. Spectrographic data soon reveals more. Ratios of oxygen isotopes do not match any known catalogue. Its chemistry carries the scent of alien origin. Frozen volatiles trapped in crystalline lattices, formed under a different spectrum of starlight. For scientists, 3I Atlas becomes a window into another planetary system, a relic hurled across interstellar space by forces unseen. It has wandered through the void for millions, perhaps billions of years, its surface scarred by cosmic rays, its core still whispering the chemical stories of a world long gone. As it drifts closer to the sun, its activity begins to change. Sublimation drives gas jets that alter its spin. Observatories capture flashes brighter than predicted, bursts of energy from within. The object seems alive with tension, its nucleus cracking under internal strain. Models suggest structural instability, perhaps caused by thermal expansion or asymmetric jets of escaping vapor. Yet something about the pattern defies logic. The stress lines suggest not random cracking, but organized fracture, like something struggling against itself. Then, in the final weeks before perihelion, it happens. High-resolution imaging from Chile confirms fragmentation. The once singular object now split into luminous shards, tumbling through the solar wind. The light flares, then dims. The data is irrefutable. 3I Atlas has torn itself apart. For astronomers, it is a paradox. How could a body that survived eons of cosmic isolation unravel within days of solar approach? What forces, thermal, chemical, or otherwise, could drive an ancient Voyager to self-destruction? The fragments scatter like pieces of a forgotten message, their trajectories diverging into chaos. In the silence of deep space, humanity witnesses the death of a traveler from another star. Yet in that death lies a deeper question, one that will soon draw the attention of every observatory on Earth. In the cold stillness of deep space, silence has no meaning, yet on a clear April night the cosmos seemed to cry out. A sudden flare erupted in the constellation of Pisces, bright enough to trigger automated alert systems across 3 continents. To the untrained eye, it looked like the brief pulse of a distant star. But to those who studied the data, it was something far stranger. The flare wasn't born of nuclear fusion. It came from the death throes of an interstellar wanderer. The Atlas had split apart. Within hours, telescopes trained on the coordinates revealed a sight of impossible delicacy. A single glowing point stretched into a thread of light, then into a chain of fragments, 4 primary bodies, each tumbling through vacuum in chaotic rotation. Every shard ejected jets of vaporized gas, glimmering under the solar wind. The once cohesive nucleus of 3I Atlas had become a storm of glittering ruin spanning nearly 200,000 kilometers. Instruments measured a sudden release of kinetic energy, comparable to tens of kilotons of TNT, yet dispersed over such vastness that not even a whisper reached human ears. Astronomers around the world began calculating the debris' trajectories, but the math refused to behave. Because 3I Atlas had entered the solar system from interstellar space, its fragments were unbound, foreign to our sun's gravity, following no familiar orbital rhythm. Each piece was a variable in an unsolvable equation. The slightest jet of gas, the smallest photon pressure, could alter its course by thousands of kilometers. Some fragments would escape the system entirely, flung back into the interstellar dark. Others curved inwards, deflected by Jupiter's distant pull. But a few, tiny, fast and erratic, appeared to veer toward the plane of Earth's orbit. Across observatories in Hawaii, Chile and the Canary Islands, faint trails began to appear in deep sky exposures. Wisps of light stretched across the void like threads of luminous fog. These were the debris clouds, fine dust and ice crystals reflecting sunlight from millions of kilometers away. They formed a glowing river that drifted slowly across the heavens, faint yet unmistakable. Humanity was watching an alien object die, one that had crossed light years of space, only to fracture in its final cosmic act. Scientists debated the cause. Was it the violent temperature shift as the object neared the sun? Was it centrifugal stress from an irregular spin? Or had the comet harbored volatile compounds that ignited beneath its crust, a chain reaction seeded eons ago? Every explanation carried uncertainty. The chemistry of interstellar material was still a mystery. Perhaps it obeyed laws not yet written into our models, and so the watchers kept vigil, charting each glint, each fading echo, each unpredictable twist in the paths of shattered ice and stone. What had once been a single interstellar messenger was now a swarm of questions scattered across the night sky, but one of those fragments was different. Smaller than the rest, dimmer, faster, its orbit, when modeled, traced a faint but unmistakable intersection with Earth's trajectory. At 04:17 Universal Time, a stream of coded telemetry begins its quiet journey through fiber and satellite. Numbers flow from observatories around the planet. Position logs, albedo readings, Doppler velocity shifts, all describing the same enigmatic point of light. To the human eye it is nothing, barely brighter than a background star. But within those digits lies a question that has haunted every civilization to ever gaze upward. Could something from the deep sky be coming for Earth? Supercomputers take up the question with indifferent precision. They begin to run simulations, millions of them. Each model accounts for gravitational perturbations from planets, the pressure of the solar wind, the faint push of photons, and the chaotic spin of debris still venting gases from within. The outputs form a branching tree of probabilities, each leaf representing a possible future. Most paths send the fragments harmlessly into interplanetary space. But not all. A handful of models show a fragment, one between 20 and 50 meters across, crossing dangerously close to Earth's orbital corridor by late summer. Too small to detect in detail, yet large enough to survive entry. An interstellar rock with unknown chemistry, approaching from a trajectory no planetary defense system was ever designed to confront. In conference rooms dimly lit by simulation screens, the Planetary Defense Coordination Office reawakens dormant protocols. Emergency task forces, long theoretical, are quietly assembled. Tracking networks refocus. Radar dishes turn toward coordinates no one can see with the naked eye. This is a moment suspended between science and fate, between prediction and prayer. The data keeps coming, but each new measurement brings more uncertainty. The object's albedo fluctuates unpredictably, suggesting jets of sublimating gas. Its density remains unknown. Models cannot agree on whether it's porous like a comet, metallic like an asteroid, or something entirely alien, its structure formed under a different gravity, a different star. For scientists, it is an unsolvable riddle. How do you calculate probabilities when the very laws that govern the material are unfamiliar? Every assumption becomes a gamble. A denser object could pierce the atmosphere and strike the surface with the force of a nuclear blast. A weaker one might fragment into a harmless shower of glowing vapor. The range between spectacle and catastrophe narrows to the width of a single equation. And so they wait, eyes fixed on data streams, telescopes tracking faint pinpoints across the void. The object remains a whisper at the edge of detection, its light shifting subtly against the background stars. Every pixel of movement, every microsecond of delay, becomes another clue in a puzzle that may decide whether this story ends as a footnote or a scar. Then, in early June, the next data packet arrives. Revised orbital parameters appear on the monitors. Astronomers cross-reference the figures twice, then again. The new trajectory does not graze Earth's orbit as expected. It crosses it. Somewhere in the darkness between worlds, a fragment of an alien visitor continues its silent fall, obeying nothing but physics and chance. The countdown has begun again, and this time, there may be no margin left to correct it. At 0946 UTC, an anomaly appeared in the radar returns from Puerto Rico's Planetary Observation Array. A brief pulse. Then another, a moving echo, faint but unmistakable, metallic ice reflecting microwave frequencies in a way no known object should. Analysts confirmed it within hours. A fragment of 3I Atlas, accelerated by solar radiation pressure, was descending toward the inner solar system. Its velocity exceeded 70 kilometers per second, nearly 250,000 kilometers per hour. At that speed, even dust carries the energy of destruction. As calculations refined, the truth emerged. The fragment's path intersected Earth's orbit. Not weeks away, days. Tracking data projected a daylight-side entry, impossible to observe with optical telescopes once it crossed the sun's glare. It was too fast for deflection, too small for early interception. Humanity's only defense was observation. Above the atmosphere, the James Webb Space Telescope turned its gaze toward the approaching point of light. Its instruments recorded bursts of spectral energy unlike anything catalogued before. Molecular signatures that shifted with every minute, as if the object's surface were transforming in the heat. Complex hydrocarbons sublimated into space, leaving trails of glowing vapor behind. In ultraviolet wavelengths, the cloud shimmered green and violet, an alien chemistry unraveling under sunlight. When it reached Earth's vicinity, the fragment crossed the terminator line, the boundary between night and day like a spark igniting the sky. Atmospheric sensors recorded a brief surge of ionization over the Pacific. Civilian cameras caught nothing. The event lasted less than 3 seconds, hidden by daylight's brilliance. But to instruments, it was the signature of an object vaporizing with immense energy, its molecular bonds torn apart by the violence of entry. Scientists parsed the data in disbelief. The infrared bloom suggested a disintegration altitude higher than any meteor previously observed, above 120 kilometers. At that height, no object of known composition should have fractured so completely. Yet the readings told a different story. This fragment wasn't rock or ice as humanity knew them. It was something more fragile, more volatile, a lattice of alien minerals never exposed to a sun before. As it died, it released compounds rich in exotic silicates and carbon chains that fluoresced emerald green. For hours afterward, instruments continued to detect a strange luminescent haze drifting through the mesosphere, particles charged by solar radiation glowing faintly as they dispersed. When night finally returned to those skies, pilots reported an unusual phenomenon, a soft, shifting curtain of green light where auroras never occur. The upper atmosphere had changed, both chemically and optically. Then, as quickly as it came, the signal vanished. No debris, no surviving fragments. The event was logged, archived, and declared concluded. Scientists called it a clean atmospheric burn. The fragment of 3I Atlas was gone, but in the stillness that followed, deep space sensors began to whisper of something else, faint anomalies at the edge of Earth's magnetosphere. Unidentified particles, newly present, moving against the expected flow of solar wind. At dawn, long after the green haze had faded, Earth's upper atmosphere began to whisper its secrets. High-altitude spectrographs aboard orbital platforms detected something unexpected. Thin spectral lines, faint but precise, belonging to molecules never before catalogued in nature. The readings showed complex organosilicates and isotopic ratios that defied solar norms. Their fingerprints didn't belong to Earth, nor to any body within this solar system. These were relics of another sun, born under alien physics and foreign starlight. Across laboratories in Europe, Japan, and North America, samples retrieved by high-altitude collectors were sealed in vacuum chambers, their compositions examined atom by atom. The ratios of oxygen-17 to oxygen-18, the binding structures within carbon chains, each measurement carried the signature of an origin billions of kilometers beyond the Oort cloud. They were fragments of another planetary chemistry, preserved through eons of interstellar flight. What scientists uncovered next was even stranger. Some molecular arrangements appeared metastable, impossible to form naturally in any known thermodynamic environment. Chains of carbon and silicon intertwined in geometries that required fluctuating magnetic fields, the kind produced not by planets, but by dying stars. These were not random dust particles. They were records of creation, atomic fossils from another system's birth. For the first time, humanity held in its hands the ashes of a different sun. Yet the implications went beyond geology or chemistry. Within the molecular spectra were faint traces of organic precursors, aldehydes, nitriles, and amino-like compounds, building blocks that echo the chemistry of life. Their isotopic biases suggested they had once condensed in a protoplanetary disk, under pressures and radiation spectra alien to human comprehension. If such materials drift freely between stars, carried by objects like 3I Atlas, then the seeds of biology may not belong to any one world. Each analysis deepened the sense of connection between Earth and the cosmos. The idea that our skies now held particles from another system blurred the boundaries of planetary identity. For the first time, the atmosphere itself had become a cosmic archive, its layers inscribed with chemistry, not of this sun. And yet, there was unease. The data's perfection seemed too deliberate, as if the fragment had not merely passed through but had shared something, an encoded pattern of ratios repeating beyond randomness. Was it coincidence or communication written in molecular order? The question lingered unanswered, suspended between curiosity and dread. Weeks passed. The green spectral traces slowly faded from the atmosphere. Instruments grew quiet. The world's focus drifted back toward its terrestrial rhythms. But in the silence of deep space listening arrays, those cold sentinels tuned to the faintest echoes between stars, a new anomaly began to appear. It was subtle at first, buried within cosmic background noise, a moving signal dim but steady, traveling on a vector that intersected the outer solar system. Its spectral signature suggested motion against the galactic flow. The algorithms flagged it for review. Astronomers checked, recalibrated, then stared in disbelief. It wasn't a remnant of 3I Atlas. It was something new, another interstellar body, larger, denser, and already inbound.